Today's lesson is going to be over Day 7, Scientific Method. Our objective is you will be able to identify the steps of the scientific method. You can view this BrainPop video through Canvas on Day 7 in your modules. If you need the code, please let me know. Scientific method. So this is a series of steps for conducting an experimental investigation. So we went over our 3 different types of scientific investigations already in the last video. Right now we're going to go into the smaller scope of an experimental investigation. This is the experiment where we're proving or disproving a hypothesis. There's steps to this. We don't just go into an experiment. There are 7 steps, if you can see. We're going to observe, we're going to question, research, hypothesize, experiment, draw conclusions, and finally we're going to report our conclusions. And this is all a part of the process of the scientific method. So the first one, observe. We're going to observe something happening. If we can remember our lesson over observations versus inferences, an observation is something occurring using the 5 senses. It's a fact because we can literally see it, smell it, feel it, taste it, hear it, using our 5 senses to observe an object or an event happening. That is the first step in our experiment. So if we're observing something, for example, we're looking at it, the whole class, we're gathered around a pot boiling water. We're observing that. We can see the water boiling. We can maybe smell the heat. We can see the water vapor. And we can hear the water boiling. So we are literally seeing this happening with our own eyes. 2, we're going to question. We're going to question what's being observed. Maybe, why is the water boiling? Why is it happening? How is it boiling? What would happen if we turn the temperature down? What would happen if we turned it up? Our questioning should include an independent variable and dependent variable. Maybe we've determined that water is going to boil depending upon the temperature it's put on. And then we're going to go into the purpose of the experiment. The purpose of it is to answer these questions that we have and solve maybe a problem if we had it. Why isn't, if we're comparing to boil 2 waters and pans over heat, maybe one is boiling and the other isn't, maybe we would ask, why is this water boiling and this one isn't? We'll solve a problem on how to get the other pot of water to boil. After we question, we're going to research. We're going to find out everything that's already known about water boiling. So this is collecting our information related to the questions we're asking. We want to know about water boiling, so we're going to research it. We're going to go through the library books, magazines. We're going to see what other scientists have done and maybe use the internet to find out everything we know about water boiling before we even just come up with a hypothesis. Now, after we research, we can make a hypothesis. We're going to predict an outcome to the question based on our research. So based on our research, let's say one scientist said that water is going to be boiled at 90 degrees Celsius, and another scientist said water can be boiled at 100 degrees Celsius. Well, how about let's go in between. Let's figure out let's say water could be boiled 95 degrees Celsius. Maybe that's what we want to figure out. So we're basing our hypothesis off of research we already found out. And it can be tested. So we can literally find out in a science lab at school if water can be boiled under 95 degrees Celsius. Something that would be untestable would be like if we said, what's the boiling point of a glacier? That's not testable because it's impossible for us to go and get a glacier from one of the poles and bring it here to test it over a hot plate. It's just impossible. So if you're going to make a hypothesis, it needs to be testable. And it must have an independent and dependent variable. Again, let's make our testable hypothesis more specific. Let's say we came up with this. 100 milliliters of water will come to a boil at 95 degrees Celsius after 1 minute. So that would be a good hypothesis to test. We have an independent variable and a dependent. The water is going to boil depending upon the temperature it's put on. For those of you who don't know the definition of a testable hypothesis, it's an answer to a scientific question that is based on observations and data and can be proven true or false. So we can prove if our 100 milliliters of water will boil after a minute if it's on 95 degrees Celsius temperature. We're either going to prove ourselves right or wrong. Now we're going to plan our experiment. We know what we need to test, we know what we're trying to find, and we're going to plan it out. No one should go into an experiment blind. In other words, you don't just go into a lab without having step-by-step procedures. You need to know step 1, step 2, so forth before you start an experiment, especially if you have more than one group testing it, and if you're going to test an experiment over and over again, like most scientists do, the experiment needs to be tested the same way each time. With that being said, you also need a list of tools needed so that each time you're using the same tools. For our experiment, we would have, well, first off, the step-by-step procedure would be example like fill a beaker to 100 milliliters. So a tool we need would be a beaker. And then the next step would probably be put it in a pan. So we need a pan, and then we need a hot plate as well, things like that, a thermometer. We're going to need all those tools to safely and accurately conduct this experiment. And then we need materials. We need a list of materials. Obviously, if we're going to boil water, we need water. We need water. And I might even put pencil, paper, stuff like that you need to plan this experiment, to do this experiment. Last but not least, we're going to create a data chart. I'm sure you've heard this 100 times before in life. If you didn't take a picture of it at this point in the age we live in, if you didn't take a picture of it, you didn't take a video of it, it didn't happen. Same thing in science. If you didn't take data, record your data in a chart or something like that, record your results, it didn't happen. So you need to make sure you're recording what's going on in an experiment every time you conduct it. After you plan an experiment, now you can conduct the experiment. You're going to have your independent and dependent variables as you conduct this experiment. It's going to be a fair test. We already determined that during making our hypothesis. We know it can be conducted, everyone can do it, and only one thing should be tested at a time, whether water can boil under a certain temperature within an amount of time. The purpose of this experiment is to gather evidence to either support or disprove our hypothesis. We're either going to prove ourselves right or wrong. So this is an experimental investigation, literally the experiment. We're involving a cause and effect investigation with the hypothesis. It either is or it's not going to boil under 95 degrees Celsius within a minute. We're either right or we're wrong. So while we're doing our experiment, we are recording data. Remember when we talked about qualitative data and our quantitative data, we're going to talk about the quality. Remember, quality, qualitative. We're using our 5 senses. We're going to look and see if it's boiling. If it's not, we might look for steam, stuff like that. And we're going to record all of this data while we're doing this experiment. The quantitative data, probably what we need a lot in this experiment. This is going to be the quantity, the amount. We're going to need to know the amount of time. We're going to need a timer. We're going to need to record the degrees Celsius that we put and the milliliters for us. So we're recording every single thing we're doing. Okay, once we're done with the experiment, we're going to graph the data. Water did or didn't boil at 95 degrees Celsius. We're going to analyze the data. If you don't know what analyze means, it means to study the parts of something carefully and look for patterns. So if we're in a group, we're going to look for patterns. Maybe if we had 5 groups in our science class, did everyone did or didn't boil at 95 degrees Celsius in a minute? Did everyone's or didn't it? And then we might go back and if no one did, then we might go back and say, okay, well, what happens at 100 degrees and see if everyone did. We're either prove ourselves right or we prove ourselves wrong. So analyzing that data will not only help us come to a conclusion, it'll help us maybe calculate averages, look for those relationships, so maybe we can conduct this experiment and figure out how to boil that water under the appropriate degrees. Just so you know, a conclusion is a statement explaining the results of an experiment, do or do not support the hypothesis and why. So for us, if we did a minute, this was just, a random example. I haven't actually tested this, but from what I know, based on our research, is that the boiling point of water is 100 degrees Celsius. So more than likely, we might have been wrong. And that might have helped our first observation. We determined one pot was boiling and the other wasn't. Maybe the other wasn't because it was too low. We saw that we did it under 95 degrees and none of ours boiled, then it was definitely too low. So we would try 100 and see if that worked. Okay, so then we could draw that conclusion based off of that. After we figured it out that it doesn't boil at 95 degrees Celsius, we would show what we came up with. There's no point of finding out something new if you don't share it. That's the whole point of doing experiments, so we can find out new things. Now, if the point of this is if in real life, if I didn't want to conduct this experiment and I was by myself, I would have done research. I probably would have stopped right there because I probably would have seen that many scientists, so many, have figured out that the boiling point of water is 100 degrees Celsius. And I would have stopped right there. There was no need for me to even do that experiment because of the research I found. Based off those results, I would have found out that fact or that theory, and I would have just stopped right there. So if we ever find something new, we want to share it so that other people can stop right there. And if they choose to try to find something new, that's them. But if I was writing a report or something, I probably would have just stopped rather than conducting an experiment to find something new. So a new discovery is not any good if you keep it a secret. All right, so that's our lesson for today over scientific methods. Please go to Canvas and please complete that. You can access the link through Intro to Science Day 7 page. Contact me if you have any questions about this lesson or need any help. And take it easy.